Good evening everyone, welcome back to another daily Leetcode challenge video. Today is 14 March 2023 and we are going to do question number 129, sum root to leaf numbers. Before moving on with the video, I request you all to please like, share and subscribe the video. It motivates me a lot. So now move on to the question. We are given the root of a binary tree. Please note that it's a binary tree, not a binary search tree. Both are different. Please comment down the difference if you know it. Now let's see what the question is saying. The question is saying that we are given the root and we have to give a total sum of all root to leaf numbers. And what is the path from root to leaf? First understand what is a leaf node. A leaf node is a node with no children. So in this case, if it has no left node or no right node, it is called a leaf. Okay, so move on to the example and see how it is exactly happening. So in the first example, the path from root to leaf is this, that is 1, 2. And the path from this root to this leaf is 1, 3. So we have to return the summation of it, that is 25 in this case. Okay. And in the second example, let's apply the same logic. What the question is saying, that from 4 to 9, then 9 to 5. So it is 495. Then from 4 to 9 and then 9 to 1. So it is 491. Then from 4 to 0. So what it is? It is simply 40. So if we add it, we are getting 2 and 2 get carried, that is 1026. So we are getting 1026 and that is our answer. So that is they want you to tell you. So the question is very simple if you know this method, that if you think logically, that at every node you are increasing the unit by tens. It is ones, it is tens, it is 100 and it is 1000. So for that you can make a variable called current, and current will be initialized with 0. Okay, and when you come here, your current is currently 0. You will update your current with 0 into 10 plus the node value, that is 4 in this case. So for first value it is 4. When you go to the next value, your current will again be updated to what? Current is 4 into 10, because you are moving one space at a time, that is you are moving 10 space, you can say. So 4 into 10 plus 9, so you will come to 49, and that was our answer. And when you come to the here, you will do 49 into 10 plus 5, that is 495. So your this path is returning 495. Same goes for this path, that is returning 491, and same goes for the third path, that is returning 40. So that is what you have to do. Let's see in another example. Let's make a dry run for it. Let me change this example like this. Let's put the some values, that is let's update it to 8 and let's update this to 4. So if we do this, we are from this path we are returning 495. Okay, and from this path we are returning 491, and for this path how much we are returning? 484. 484. So if we add this, we are getting how much? 10, 1 get carried, 7, 2 get carried, 16, 70 is your answer. So how is this happening? At every level you are just increasing the unit, that is 4 is at unit place, then you are coming to tens place, that is 90, then again the position increase, and that is 100 space. So ones, tens, 100, that is how you are getting the positions. At every step you simply multiply the current value by 10. If you are not clear with this concept, please check out my other videos, and it is very simple if you think it mathematically. Okay, and if you have any doubt, do let me know in the comment section. So this was the whole logic, but how do we actually do it? If you have seen the previous yesterday's video, we simply applied recursion on tree questions. What we do, we take a leap of faith that recursion can do it. So we can check whether if root is null or not. Root is null or not. If root is null, we simply return null. Okay. If root is not null, we have to check for leaf. What is a leaf? Its left and right both are null. So we check, that is root left and root right. Okay, and both should be checked with null, whether they are null or not. Okay, and if they are null, that means it is a leaf node. In that case, what we return? We return the current value. And how are we getting this current value? We will do a leap of faith recursion. So first iteration will be, first thing will be to update our current. Current is initialized with 0. We update our current with, current is equal to current into 10 plus root value. That value is put here and we are updating our current. But how do we go to left and right? It's very simple. We will write int left is equal to the function name, let's say solve. We will pass root left and we will pass the current value. Similarly for right, we will pass int right, solve, root right and the current value. And what's the last step what we have to do? When we have all the values returned from all the leaf nodes, we simply add all the values. So we return our left plus right. So that is all you had to do. Just take a leap of faith recursion and you can do it. 3 questions are best to understand recursion, and you just have to apply a little bit of mathematics to understand this 10 into current method. That is, at every step you are moving a tens place. Okay, and that is all you had to do. So without wasting any time, let's move on to the coding part, and let me just zoom it for you. So for the coding part, let's make a function int solve, or let's say int add, and inside that, what I told you, we will pass the tree node root and we will pass the variable current. Okay, and we will check if root is equal to null, we return null. Yes or no? Or instead of writing this as root is equal to null, you can write it as root not. That is the same meaning as root is equal to null. After this, you will update your current to current into 10 plus root value. After this, you also need to check if our root left is equal to null and root right is equal to null. That means it is a leaf node. It is leaf node checking. In that case, if it is a leaf node, you will return the value of current, whichever value is there. If it is not a leaf node, you will check for the left, and for checking the left, you will do int left is equal to add root left and you will pass the current value. Same goes for right, add root right and you will pass the current value. You are taking a leap of faith with recursion. You can solve any question. Recursion is a very useful tool if you understand it. Please watch some recursion videos. You can check out my playlist, my videos as well. And finally, you will return left plus right as your answer. That is all you had to do. And let's complete this main function. We will pass it in our function return add. We will pass the root and the current value is initialized with 0. That is all you have to do. Now let's just run and check whether it is working or not. We haven't current. Oh, we haven't initialized the data type. It is int current. Yeah, it is running. First case 25, second case 1026, and third case is 1470 as explained here. Let's just submit it. So yeah, it is working. So the time complexity and space complexity, you guys comment in the comment section. Thank you so much for watching. I request you again to please like, share and subscribe. Bye bye. See you in the next video.